I'm going to be talking about the lac operon that happens in eukaryotes, and it's controlled by two signals, the presence of glucose, no, the absence of glucose and the presence of lactose, but I'll get that further. So in the lac operon, there's a cap binding site, an RNA polymerase binding site in the operator. And if glucose and lactose is present, then the lac operon's off, because there needs to be a cap on, there needs to be an RNA binding site, and there needs to be tryptophan attached to the cap. But if there's a low concentration of tryptophan, the RNA polymerase will come and bind to this. But if there was a high concentration of tryptophan, then the receptor would come and bind to this, and transcription would not happen. It won't turn. It'll turn certain genes off. But if the cell needs glucose but there isn't glucose, then it's gonna turn the lac operon off and use other alternatives to find carbon elsewhere. So if the receptor is on the lac operon and glucose is present but lactose is not present, then the lac operon is off because glucose is present. In order for the lac operon to work, glucose needs to be absent. But if the cap comes along with the tryptophan and the receptor comes along, the lac operon is off, because again the receptor is preventing genes being turned on. So anytime the receptor is on the lac operon, transition is not happening, enzymes are not being made. But if you have the cap there and the tryptophan and the RNA polymers, then the lac operon is on. Only if glucose is absent and lactose is present. And that's it.